In this video, I'm going to show you how to use integration to find the area bound by a curve and the x-axis. Let's take this curve y of x and say we want to find the area between this curve and the x-axis from x equals a to x equals b. So we just want this inside portion here. So how do we find this area? The trick to doing this is to think about breaking it up into a bunch of smaller rectangles. So the area will be the integral from a to b of the area of a rectangle. We're summing up the area of all those smaller individual rectangles. And an individual rectangle has an area given by the height of rectangle times the width of rectangle. And the height of rectangle is just given by the height of the curve at each point. It's just the y-coordinate. So height is just y of x, and then the width of a rectangle is just an infinitesimally small section of the x-axis, so just dx. And here we've got our general formula. Area is the integral of the function representing the curve from the left x-bound to the right x-bound. So this is our master formula, and this is what we're going to be using to find the area of some curves. Here's a concrete example where we want to find the area between y equals x squared plus 1 and the x-axis from x equals 1 to x equals 2. So we want to find this inner area right here. And we're going to do that using our master formula. Area equals integral from the left bound, -1, to 2 of y of x dx. Now it'll give us that area inside of there. Okay, so now we just have to substitute in y of x, and we'll get integral from -1 to 2 of x squared plus 1 dx, because that's our formula for y of x. And then we can go ahead and evaluate the integral. So that's just integral of x squared is 1/3 x cubed, and then integral of 1 is x. And we're taking that at the bounds -1 and 2. So at 2 we've got 2 cubed is 8, so we've got 8/3 plus 2 minus -1 cubed is -1, so -1/3 minus 1. And we'll go ahead and compute that. Let's just distribute the negative sign. We've got 8/3 plus 2 plus 1/3 plus 1. And 8/3 plus 1/3, that's 9/3, and then 2 plus 1 is 3. So we've got 3 plus 3, which is just 6. So this inside of the curve just has area of 6. Here's another example, which is a little bit trickier because we have to actually get some of the information from the problem before we set up the area integral. So we want to find the area of this closed region between this function y equals x squared minus 4 and the x-axis. So we want that area right here. So how do we find this area? Well, we can set up our area integral. Area equals the integral from the bounds of y dx. But we don't know the bounds. We need to get the bounds first. So the bounds are going to be where it crosses the x-axis. Right here and right here. So we really just need to figure out the x-intercepts of the curve. So let's do that right here. We can find the x-intercepts by setting y equal to 0. So 0 equals x squared minus 4, and then can just add 4 to both sides. 4 equals x squared, so plus or minus 2 equals x. Great, so this intercept is -2, and this intercept is 2. So we're really going from x equals -2 to x equals 2. And we can go ahead and fill that in our bounds here from -2 to 2. And now we're ready to go ahead and evaluate this integral. So let's substitute our expression for y. It's -2 to 2 of x squared minus 4 dx. And that's going to be equal to, let's go ahead and compute the integral. Integral of x squared, that's 1/3 x cubed. And integral of 4, that's just minus 4x. Evaluated at the bounds, -2 and 2. So let's go ahead and plug in 2 here. So 2 cubed is 8, so 8/3 minus 4 times 2, it's also 8. And then minus at the other bound, -2 cubed is -8, so -8/3. And then -2 times -4 is plus 8. Alright, so let's go ahead and distribute our minus sign. 8/3 minus 8 plus 8/3 minus 8. And then we'll combine 8/3 and 8/3 makes 16/3. And minus 8 makes minus 16. So that's 16/3 minus 48/3 if we multiply by 3/3. And then we get -32/3. This is a negative answer because our area is under the x-axis. But so to find the actual area, we just want to take the positive answer. We want to take the absolute value, just 32/3. And that will be our area answer. Here's another tricky example. This one's a little bit tricky because we actually are going to need to split the area up into 2 segments. So we want to find the area between this function and the x-axis. And we've got a section here that's below the x-axis, and another section here that's above the x-axis. And we're going to need to compute these areas separately, because when we compute the area using the integral, this area is going to be negative and this area is going to be positive. And we don't want to subtract the areas at all, we just want to add them. So we're going to need to convert this to be a positive area first. So let's go ahead and label this as area 1, and then this area can be area 2. So area 1 is just given by the integral from x equals -2 to the crossover point, which is x equals 0, the y-axis. And that's the integral of y dx. We've got our expression for y, and we'll substitute that in. Integral from -2 to 0 of x cubed dx. And we can go ahead and do the integral. That's 1/4 x to the 4th, validated at the bound 0, -2. And plugging 0 in, we just get 0. Then minus, plugging -2 in, we get -2 to the 4th is 16, and that's over 4. So we've just got 0 minus 4, so just minus 4. Okay, great. Now we'll need to convert that into a positive area, positive 4, for when we do the addition of the areas. All right, now we can do area 2. Area 2 is the integral of the left bound is now the crossover point, x equals 0, and x equals 3 is the right bound of y dx. So that's the integral of 0 to 3 of x cubed dx. So we'll go ahead and take the integral of 4th x to the 4th from 0 to 3. Now 3 to the 4th, that's 81 over 4th. And then 0, when we plug in 0, everything just goes to 0. So that's 81 over 4. And then that's our answer for the second area. Okay, so now we can go ahead and find the area total area. And that's going to be the area of the first region plus the area of the second region. and that's just equal to 4 plus 81 over 4. And then, so 4 is just 16 over 4. And then when we add 81 over 4, we're going to get to 97 over 4. And that's going to be our total area. So this will box nice and heavy because this is the total area between that function y equals x cubed and the x-axis from x equals 2 to x equals 3. Here's a final example, and this was going to be the trickiest because we're also going to have to break this one up into two different areas, but we're not actually given the point at which we need to break it up. So we're going to break it into an area that's below the x-axis. This will be our area 1. And then we need to break it into another area that's above the x-axis, and that'll be our area 2. Okay, but we still need to figure out what the point of breakage is. Where's the crossover point where y changes from negative to positive? And so that's just the x-intercept here of this curve, and we can find that by setting y equal to 0. So 0 equals 3x squared minus 3. So then adding 3, we've got 3 equals 3x squared. 1 equals x squared. So plus or minus 1 equals x. And so this intercept right here is negative 1, and this one is positive 1, and that's the one we want, x equals 1. Okay, so now we're ready to go ahead and break up the areas, and we'll find the areas, we'll add them. So area 1 is equal to the integral from 0 to 1 of our curve 3x squared minus 3, and we'll go ahead and compute that. So 3x squared, the antiderivative of that is just x cubed, and then minus 3x. Evaluate at the bounds 0 and 1, so that's just 1 cubed is 1, minus 3 times 1 is 3, and minus everything turns to 0 when we plug in 0 in, so we've just got negative 2. So area 1, we want a positive area, so we're going to take positive 2, and that's our area 1. Now we can find area 2. That's going to be the integral of from the crossover point 1 to the right bound 2 of our function 3x squared minus 3, and we'll go ahead and take the integral, so that's just as before, x cubed minus 3x, validate at the bounds 1 and 2. We'll plug in the 2, and we get 2 cubed is 8, then minus 3 times 2 is 6, minus plug in 1, we've got 1 cubed is 1, minus 3 cubed is, or minus 3 times 1 is 3. Alright, so this is 2 minus negative 2, which just comes out to 2 plus 2 is 4. So area 2 is 4. And then the total area is going to be the first area, 2, plus the second area, 4. And that'll come out to 6. So 6 is the total area between this curve and the x-axis between x equals 0 and 2. In the future, we'll extend this idea of using integration to find the area bound by a curve and the y-axis too.